My friends, today I will be continuing my work from yesterday on Model Mania 2011. So yesterday we stopped at the end of phase 1. We were working on Model Mania 2011, which is SolidWorks design, and we're just practicing on it. And it asks for a phase 2. So we'll have to modify this model to this model. The main difference is here. So in phase 1 we have a blocky outlook from the side, a rectangular outlook where we can see that this main body is converted to a curved shape. So we will have to go back quite a bit to actually implement this, because the way we built phase 1, I don't think it's suitable to easy transition to phase 2. With that, let's go ahead and start working on it by some cleaning up. First of all, we'll have to clean up the text draw. We don't need that anymore. And then I will delete this fillet part because I don't want to do any edit inside with the fillet outside. I'll also want to delete the connect and maybe this shell, because I want to come up with a new idea. I want to keep this top sketch, but I don't think this profile would help us anymore. So let's go ahead and delete that. What is this? Okay, I don't need this sketch as well. So I will be keeping only this sketch, and like it's a very minimal retaining from the previous model. And here I want to go ahead and build this as a full sketch. So I'm going to take the whole thing and mirror it over on the other side. Now because I'm working on FreeCAD 0.22, the developer version, the sketching part is a bit different. So if you are still working on 0.21, you may see some outlook differences, but know that the basic operations are the same. The FreeCAD 0.22 version is just a bit more user friendly. I like it. I really like it. Let's go ahead and make these two same point and these two. And we'll have to place, okay, they are okay. So we have 3 degrees of freedom. One of them is placing this point on this axis and then apply some dimension, which is 30. We have 1 more degrees of freedom. Let's find out. Okay, this center would be the same, and that's a fully constrained sketch, which is like how this object would look like if we are looking from the top. Now I want to build another sketch that would look like from the side. So we want to use this image. So let's go ahead and do some processing on this. And I want to calibrate this image, so we know that the center to center distance is 60 real quick. And then I want to make it half transparent, and I want to place it on the front face. There it is. And now I want to relocate this image to match with this existing sketch. As I said, I want to build a sketch now that would look what it looked like from the front side, and I want to start with a polyline. So there is a 6mm fillet that we know on the around this body, which we can see around this area. I don't want to build that fillet right now. I just want to make it like this, and then maybe fix this line first, make it symmetric by the axis by pressing S on the keyboard, and then providing the depth dimension here by pressing D on the keyboard and say 30. right? And what else? We have 3 degrees of freedom and the length of this line, which would be 100. Okay, and then we'll have to make this arc. We'll have to find the center. I don't think this will work out for us. Let's go ahead and delete that and create an arc manually by 3 points. So here is 1 point, 2 points, and I want to match it with this origin. Find that origin, place it up there. Okay, we have it. Maybe we'll have to place this center on this axis, right? And then finally the radius of this arc, which is 70. So we got a fully constrained sketch. As I said, I don't want to do the 6mm fillet at here because I'll have to apply it around the body. Without that, we have one sketch that looks from top and another sketch that looks from the side. I want to extrude both of these, and the top one I want to bring it down to say more than what I need, and it would go downward. And on the side one I want to make it symmetric for more than what I need, but it would be symmetric. Now these two bodies are crossing each other. I can go ahead and make a common Boolean operation that gives us the core of this body. Now I have two options. I can go ahead and apply the 6mm fillet right now, and then I can do the thickness, but I have a hunch I'll have to do the thickness first. Let's go ahead and do the thickness right now. I want to keep it there and then come back to the data tab and update it to -3. I don't know why I do that, but sometimes it helps. And we have the thickness tab applied to it, so we have the shell prepared. Now I can go ahead and do the outside, that 6mm fillet. Now given how it looks, it's like, you know, all curvature on both sides. This fillet is really important. There is no other way to actually build that edge without the fillet. So let's go ahead and apply it 6mm fillet around it. And if you will notice, now we have a smooth side outside, but that inside is kind of like it's not smoothened. What I mean by that is, let's see if we can hide these two and then view a cross-sectional view on the X side. Maybe flip the side. Now you can see this is a little not that easy to see, so we will go with view and persistent section cut, and on the X side we're going to flip the side. Okay, now it is more clear. From here you can see that at this point this is smooth curve outside, but inside is not. So the thickness is 3mm here, but here it's definitely less than 3mm, so we need to bring another curve here. So if outside is 6mm, we want to make it a 3mm thick wall, so inside would be 3mm fillet. We close that part, we create something else. I'm going to go ahead and delete that. Okay, and now I select that edge there and then create a 3mm thick fillet around here. Now we have an uniform wall. If we see, look at through the cross section. Okay, we are making good progress. Now we have to do 2 holes with some protruding columns outside, and I want to do that via tube, and the outside diameter is 14 and inside diameter is 11, well, the radius is. And on the height, I'm going to go ahead and make it 20 for now, and then we'll come back to it. So I want to flip it upside down, that will help me place it where it should be and update the height as we need. Okay, so now it is at 0. Placement on the Z direction, it's at 0 where we want it to be, right? And so that's where we want it to be, at this level, at the 0 level. And then I want to move it sideways, so that would be X direction dimension 30. And now I want to go ahead and mirror it over on the other side. So if it moves on X direction, it will go on YZ plane as a mirror plane. Okay, now we have these coming downward, and as I said, we'll have to update that height in a minute. But before that, let's go ahead and do the connecting between these two as we did in the first phase. We got that part taken care of. We don't need any updating on that, at least, so that's good. Okay, now on this one, so we want to do the connect. So select that and select the main body and hit connect. As you can see, this upper side is not there, it's actually in the downside, because the way it works is it will keep the longer side after cutting the face. So this side is like longer than what we have in the outside. So that outside is gone, inside is there. We want to flip it. So what I'm thinking, I go back to that tube here. So that's the one. And I reduce the height with a trial and error basis. So I'm gonna go say 19, no change, right? Make it 18. That changes. So that changes. What it does is it smooths out inside, although it's not crossing all the way. It smooths out, and outside it keeps it. And that is why I like this tool, connect object. Makes life a lot simpler. Now let's go ahead and do these two, the same thing. Because it was mirrored over, we don't need any adjustment on that side. All right, I think that's all other than the filleting. So I'm gonna go ahead and apply the fillet right now. The main body is built. So since we did this little height adjustment in phase 1, I want to keep that, no change in there, and then go ahead and apply a 3mm fillet. Beautiful. And then we want to do another 3mm fillet on these two. So maybe we can do it from the same face. So select this and this. So we'll have to select on both sides just to be on the safe side. And all of them will be 3mm. It worked. Pretty cool. So we have built the phase 2. Let's go ahead and save it as phase 2. Okay. And now it's time to do some FEM analysis. So let's take at the parameters one more time. We are looking for material A1 AISI 1020 material, and then we will fix these two faces inside these cylinders, and then on the vertical two tubes we will apply 3000 Newton load on each side. So let's go ahead, open up our FEM workbench, and then start with an analysis container and add a solver to it. After that, the next step is to apply some material, and we are looking for AISI 1020, which is not here. I looked through it and it's not here. So we are looking for 1020. It's not here. So let's do a quick Google search on the yield strength of 1020. So what I find is AISI 1020 steel cold rolled. It has a tensile strength yield strength, that's what we're looking for, is 350 megapascal, and we don't have that library in that material. So let's go find something close to it. What I do is I pick one, say 1C45, right? And then actually use this FreeCAD material editor, click on there, and then see what the yield strength is. So on this one, luckily, 1C45 has a similar yield strength of our 1020 material, just 10 megapascal less. So it's like, it's in the area, it's like 3% less of what it should be. So we will use 1C45 for this property, for this material, and then go to the next phase, apply a fixed phase on this one and through there. We got the two fixed phases. Now it's time to apply load. We will do 3000 Newton load on this phase and this phase separately. So there, I want to add this phase. Okay, it's going upward. Let's go make it downward and then apply 3000 Newton of load. Let's do the same on this phase. So another load. I want to add this phase, and then I want to say 3000 Newton direction. Okay, so it's not showing the direction of the load. I remember clicking reverse direction on this one, but so I am working on FreeCAD 0.22 developers version. It's not a stable release, so maybe there is a bug. If somebody knows what's going on, let me know. Let them know. No. Let's see if the load is applied. I can see the load is there. Hopefully it's there. It's just not showing up. So we have the support, we have load, we have material, and this analysis solver. We have all except the mesh, and I want to go with Gmesh. The N mesh hasn't worked out pretty good with me on complex surfaces last couple times. So Gmesh, yeah, let's give it a try with the default values. So we are looking for something that says something without red. Okay, no. So on the last line it says Gmesh done, but it's in red, which is not good. So change that to first and apply. So it worked last time on a different model, the first element order. Okay, now it has still warning, but the Gmesh done is not in red. And I think that is okay. We will find out. Okay, we go to solver and write INP file and then run Calculix. Oh, that was fairly quick and it worked. Calculix done without error and it's not in red. So my way of interpretation all these lines is anything red, bad. Everything black and white or like some other color, good. So it's good. Okay, let's take a look at the results and see if this load is there. We will see from the displacement. Looks like it's there. Okay, the maximum displacement is 24 micrometer, which is very negligible. Looks like it's a well-built model for this load at least. I want to look at the displacement and see how it is moving downward here, which tells me the load is there in the calculation. It's just not showing up. So the bug is preventing the display, but not the work. Okay, let's talk about the stress. We have a 60 MPa stress and our maximum allowable stress is 350. So we have about 6 factor of safety, which is better than good. I mean, more than enough or something like that. All right, so I think this experiment was pretty good, and also in developer's version. Uh, except this load is not showing up. I think everything went smoothly, especially how this fillet worked here, even though there is not 3 mm vertical space between this surface and this surface. That fillet worked great, which exceeded the expectation of my expectation in FreeCAD filleting. Given my previous experience with fillets in FreeCAD, this is great. Anyway, hopefully you enjoyed this video, the whole process of switching between phase 1 and phase 2, and also doing the FEM analysis, looking at the results and see if it is good for this loading condition. If you have any question, comment or suggestion, let them know in the comment section. I appreciate those comments, and thank you for watching. I will see you in the next video.